All right. So class, hopefully you're here because maybe you missed class because you were at the play, or maybe you just like watching my videos. But either way, what I'm going to do is I'm going to run through um, the solutions quick so that it makes a lot more sense for when you get to writing your own balanced chemical equations and describing what state these substances are in. All right? So I'm not assigning any more work. All I'm asking is that you understand how to determine if a solution is if the substance in the solution dissolves. So it is soluble or insoluble. All right, so I'm going to run through the notes that you missed so that you're caught up. Okay, so you should just do, it should just say side 1 of worksheet 2.2 and your lab. Okay, so try to get your lab done for 1.1, and at the end of this I'll run through the most common question from the lab, and if you have any more, please ask. All right, so let me figure this out. So where we left off was describing what dissolves in what. So like dissolves in like is the easy way to remember that. So polar dissolves in polar, nonpolar dissolves in nonpolar, ionic fits in with polar. So ionic dissolves in polar because they both contain charged substances. Polar is partially charged, ionic is completely charged, but they're both like one another. Okay, so to be able to determine if something like a covalent substance is polar or nonpolar is tricky, and that's something that we're going to take a whole unit to study. For now, remember hydrocarbons, anything that's just carbon and hydrogen, for example this C6H6 or CH4, anything that's just carbon and hydrogen is always nonpolar. Okay, most other things we're going to look at that are covalent for now are going to be polar. Okay, the most common is probably going to be alcohols, which is a carbon, a hydrogen, and a OH, okay, at the end of it. So those are polar. So just remember nonpolar substances, okay, covalent substances are hydrocarbons, okay? All right, so here's an example of a polar and a nonpolar mixing together. So obviously they don't mix. It looks all funky like this, and they sell it at Walmart as lava lamps. Okay, all it is water, which is polar, wax, which is nonpolar. Okay, so they don't like each other. They do not mix together. This is just like oil and water. Okay, if you mix oil and water together, one's going to float on the other. Okay, oil is less dense, so it's going to float on top. All right. Now, when they do mix together, I can control how they mix together by changing things like temperature, grinding it up, stirring it up. So I can change how things dissolve by increasing the temperature, increasing the surface area. Gases can also dissolve in a liquid. Okay, gases like CO2 dissolve in soda. Okay, and that's what gives it the fizz. That's what makes it taste good. That's what people want. And it's going to decrease when I increase the temperature. So you don't want to drink warm soda because it's flat, okay? And also it's warm, and you usually drink it to refresh yourself or cool yourself down. Gases, the solubility of gases also increases. Oh, and I put this picture over it. But the solubility of gases also increases with the increase in pressure. So if you have greater pressure, that's going to hold that gas in the solution. So when I let it go, oh, here it is, and I decrease the pressure, what happens is that gas becomes less soluble, so I see the bubbles come up and leave. Okay, they're not all going to leave, but some will leave when I open it up because I'm decreasing the pressure. So solids tend to dissolve best when heated, stirred, or ground into small particles. Gases dissolve best when the solution is cold and the pressure is high. Okay? So that's to summarize things. And how do I dissolve things best? Now, there's always going to be an exception to everything, so this is a chart showing that most things increase with their solubility with temperature. Cesium sulfate doesn't. There's always going to be some exceptions for any rule I say, so get used to that this year. All right, so here we see the decrease in pressure once I open it up. That gas becomes less soluble and leaves and takes with it a bunch of soda, okay, and that can cause a mess like it is here. All right, so solubility and ionization is the key thing we need to grasp. Okay, so there's a couple huge points, and I want to focus on this for a second. Solubility means it dissolves. Okay, ionization means it breaks apart into ions. So What dissolves and doesn't break apart into ions? Sugar. Okay, sugar is a covalent substance. It's polar, so it dissolves in water. Polar dissolves in polar. But it doesn't ionize because it's not made up of ions. Okay, ionic substances are made up of ions. Okay, so ionic substances that dissolve in water ionize, and that's the key point. So ionization is when I have a positive or negative ion floating around in a solution. And what that can do is it can carry a charge, and it can carry electricity from one point to another. So that's what I see here. Okay, so here I have a solution of salt water, okay, and it can carry a charge. When I put this light bulb with an open circuit in here, I have it plugged in, so it's not producing electricity, okay? But what it's doing is it's carrying the charge from point A to point B, okay, between my two circuits here, okay, and that's ionization. All right, sorry, let's make this full screen and you can see it better. Oh, maybe I can't. There we go. So again, this is salt water. When I put it in, okay, the light bulb lights up because this is an ionic solution dissolved in water. So ionization has occurred. Okay, this one is sugar. Okay, sugar water. Nothing happens because it doesn't ionize. It doesn't contain ions. It doesn't break apart. It doesn't carry a charge. Okay, so nothing happens. Okay, sugar water, and this would happen just with just distilled water as well. Salt water. Okay. All right. Uh-oh. Just give me a second. I got my computer all wet. So I need to get out of full screen. Sorry. Come on. All right. All right. So that if it ionized, it's a conductor of electricity. It can carry a charge from point A to point B. Okay. But who conducts electricity? Things that ionize completely conduct electricity. Things that partially ionize do conduct electricity as well, but not as good. Okay, so strong electrolytes are soluble salts, anything that dissolves in water. And I'm going to go over in a second how do you tell if a salt is soluble or an ionic compound is soluble. Okay, a salt is any ionic compound formed from mixing an acid and a base together is a salt. Okay, so there's all sorts of salts. Sodium chloride isn't the only one. Potassium chloride, magnesium fluoride, they're all salts, ionic compounds. Okay, so they break apart in water because water rips them apart. The positive part of water attaches to the negative ion. The negative part of water attaches to a positive ion, and it breaks that crystal lattice apart. Okay, and it breaks them up into ions, and that was the first part of your homework that I had you do. Okay, separate ions. Notice again, if I have more than one, like chlorine in the compound, the formula unit, it's going to produce 3 chlorines. Okay, this right here. Okay. All right. So understand concentration. We'll go over this more, in class later. But for every 1 iron, I have 3 chlorates here. Okay, so understand how many of each ion there are when you break it up. So on your homework, magnesium chloride breaks up into magnesium and chlorine. Aluminum nitrate breaks up into aluminum and nitrate. Okay. All right, huge point number 2. How do I determine if an ionic compound separates into ions? So this, I use the solubility rules. Solubility rules, there's 10 of them. You're going to become familiar with them. More and more, there's 3 that you really should focus on. You don't need to remember all 10, because if you remember 5, that's what's soluble. Everything else isn't. So you don't need to remember all 10 rules. I would say 3 for sure. It's going to be great if you remember all 5, though. All right. So these are all things that are soluble. So right here, soluble means aqueous. So if it's soluble, you're going to put a little AQ in the reaction. Okay, so all of these ions are soluble. Notice there's some exceptions. So like silver chloride is not soluble. That's on your homework. Okay, that's why it doesn't dissolve in water. It doesn't ionize because it's insoluble salt. Mercury chloride, lead bromide. Okay, these are exceptions. These are the insoluble things. So look through this, and this is you also have a half sheet that has these on it. So make sure you become familiar with those. So To determine if it's aqueous or solid, I look at my solubility rules, this list right here. And I'm going to look for a rule that applies to either lead or nitrate. So lead nitrate, rule number 3. That's one of the rules that I would remember. Rule number 1, rule number 3, and rule number 4 are probably the most important. Okay? So nitrate is always soluble. So it's aqueous. Aluminum sulfide. I look for a rule that applies to either aluminum or sulfur. Typically, you're going to look at the anion or the negative ion. Rule number 9 says sulfur is insoluble, and aluminum is not an exception. Insoluble means solid. Magnesium hydroxide. Rule number 10. Hydroxide is insoluble. Magnesium is not an exception, so I would call that solid. Lithium chromate. Li2CrO4. So here we have chromate is insoluble, but it says see rule 1 for exceptions if I look at rule number 7. If I look up to rule number 1, lithium is soluble, so I'm going to call that aqueous. So what I've done is I've determined which of these ionic compounds ionize. Okay? Who else ionizes? Strong acids. And your list of strong acids is also on that half sheet. Those are 7 strong acids you're going to want to become familiar with as well. And these break apart completely. So if I had a strong acid in this container, it would light up the light bulb very bright, just like the salt did. Okay, so here are the strong acids. Hydrochloric acid breaks apart into HCl. Hydrobromic breaks apart into H and Br. Hydroiodic breaks apart into H and I. Nitric breaks apart into H and NO3. Sulfuric breaks apart into H and HSO4. It's only going to lose one hydrogen at a time, so HSO4 would lose that second hydrogen later, but that's going to be a weak acid. We'll cover that later. Chloric breaks apart into H and ClO3. Perchloric breaks apart into H and ClO4. All right, so those are my strong acids and also strong bases. Strong bases are groups 1 and 2, calcium and lower, okay, for group 2. So potassium hydroxide is a strong base. Calcium hydroxide is a strong base. Magnesium hydroxide is a weak base, so that's not going to be a strong electrolyte. It's going to be a weak electrolyte, okay? Weak electrolytes just don't ionize completely. So if they were to light up this bulb, it wouldn't light it up as brightly as a strong electrolyte does, so as sodium chloride does, or hydrochloric acid does. It would just be a little more dim, okay? So they don't ionize completely. These are any acids that are weak or not listed as strong are weak. Any bases that are not listed as strong are weak. So they might ionize 5%, 10%, 50%. It's a weak acid or a weak electrolyte if it doesn't ionize completely, okay? And then there's non-electrolytes. Non-electrolytes are anything that don't ionize at all. So these are covalent substances that dissolve in water or don't dissolve, and insoluble salts. So anything that like silver chloride doesn't dissolve in water, so it's not going to carry a charge. It's not going to produce electricity. Okay? All right, so those don't carry a charge at all. So let's do a quick practice. Pure water, does that conduct electricity? No, it does not. Okay, it's not an electrolyte. Tap water does, because there's all sorts of things dissolved in it, all sorts of ions dissolved in your tap water. Depending on where you are in the world, there's always going to be something dissolved in it because it's carrying ions with it as it moves through the pipes. Sugar, we already did that one, does not. Sodium chloride solution does. Hydrochloric acid does. Lactic acid, it's a weak electrolyte, but it still conducts electricity. So I would say it's not a good electrolyte, but it's still it's still an electrolyte. Alcohol does not. It's covalent, and pure sodium chloride does not because it's solid. Doesn't have free moving charges. So here's some examples of electrolytes and non-electrolytes. And you've probably heard this term before, electrolyte and non-electrolyte, because our body needs it. It's all over Gatorade bottles. It's those charged particles that can carry messages throughout your body. It allows for nerve impulses. It allows to transfer messages throughout your body, to allow your muscles to move, to allow you to talk, to allow you to think, to go to the bathroom, to break down things. Okay, all of these are functions that our body owes to having electrolytes in. So if you don't have electrolytes in your body and you're severely dehydrated, that's where dangerous things can happen. Okay, you can, not think clearly, not function clearly, okay? So you need those electrolytes in your body to get your body to send the messages it needs to throughout, all right?